हेलो छ कि छैन यहीमा त किन हुन्छ भनेको यार New York country dreams are made of anything you can do. Okay, let's go.
And modular, we're able to create multiple copies of the infrastructure just by changing those input variables.
I'm a software engineer at Amazon, and I learned how to code on Udemy.
Now let's take a look at some of the more advanced language features and how we can start to use them to improve our code even further. I've listed out a bunch of things here. I'm mostly just going to call them out as things that exist, and you should really use the Terraform documentation, which is quite good, to understand how exactly to use these things. Which is quite good to understand that exist, and you should really use the Terraform documentation, which is quite good to understand exist, and you should really use the Terraform documentation, which is quite good to understand how exactly to use these things. But we have access to as things that exist, and you should really use the mostly just going to call them out as things that exist, and you should really use the Terraform documentation, which is quite good to understand how exactly to use these things. But we have access to expressions on the left-hand side here, so we can do things like template strings. So if you're familiar with how you can have a string in JavaScript with a curly braces inside and reference a variable from within that string, we can do similar things here where we can build strings dynamically. We also have a number of operators which behave like you might expect from a programming language with multiplication, division, checking equality, etc. We can use conditionals, so it's similar to a ternary syntax here where you have a condition, and then if it is true, you do one thing. If it is false, you do another. So that's a pretty powerful construct. We also can use a for list. So if we want to, let's say, have a listing of configurations and loop over them to do something a number of different times, it allows us to have a configuration that we don't have to repeat the same code over and over. We also can splat. So by that, I mean take the values in a list and expand them out over some way in which we want to use them. There's dynamic blocks, there's constraints we can use to check typing and versions of things. And so, like I said, use the docs for those. We have a number of
It then builds a new tuple value.
Different functions, so things like math functions that we can do on numbers. We have date and time functionality built in, where if we wanted to have something that is named after the specific timestamp at which it was created, or if we need to use the hash and crypto functions to generate a password on the fly, etc. So there's a bunch of built-in functions within the language that you'll want to use the documentation to understand how to use these within your code base. And we'll see this as we go through and continue to build out our examples. We'll use some of these functions to help make our code better and better. Now, there's also a concept of a meta argument. There's a number of these, but one specifically that I want to call out here is the depends on meta argument. And so normally, if there's things that need to happen in a certain sequence, if you're like provisioning a server and then you need the IP address from that to pass to a firewall rule or what have you, just by passing those data and saying EC2 example.output and putting that into the configuration for the other resource, Terraform, when you run the plan or apply command, will figure out the sequence of events and the dependency graph there. There are cases, though, where one resource implicitly depends on another, but there's no direct connection within the config. And so an example here shown on the right is that here, if my instance needs to be able to access an S3 bucket, I need to have a role policy that can make that happen, but there's no direct connection within my config. And so I can tell Terraform what this depends on key, oh, you should make sure to provision this role policy before you provision the instance, otherwise it's going to fail. And so this allows me to give some hints to that, the parsing and the dependency graph generation to ensure ordering matches what it needs to be. There's also another meta argument, count, and this allows me to specify if I need multiple of the same configuration provisioned, I can use this count meta argument and it will provision multiple copies. And so usually this would be used with let's say a module.
गएपछि
मेहनत का दीप थोड़े हक से जलते अब पैसा है बाजी तो गेम पलट दे शूटर भी हैप्पी सब साथ में चलते रास्ते में गैंगे तो बंदे लफड़े चल बंदे लफड़े हाँ हमर माइंड फुल चार्ज हिरे दिमाग जना टूटल दुगो तार बाइक के अगाड़ी में जब घूमे संसार केला दिने में अनहार पूरा देश पर प्रहार जनचेतना आधार एकता में बल माने पूरे संसार एक के ठाव में तो अकेला नहीं प्यार सुख में है सब दुख में कोई नहीं आधार विश्वास के आधार पर टिकल संसार हमर बोली नंगा तार खुखरी के धार गर्दन के पार कनी क विचार न तो बोरा में पैक क सीधे वही पार सिस्टम हिलाब वाला यादव सरकार फेरि सुतिरा के भागलाई त टर्चर न दे केडाहरू जङ्गी सबै डेन्जर छ बे मामा पनि साइड मेरो ग्याङ अन द वे त्यसैले पर्दैन पर मेरो नजरमा बे मेरो छुट्टै कहानी जनकपुरदेखिको यात्रा राजधानी बर्दी बासमा त्यो होटलको साउनी भट्कायो ध्यान मेरो रन किने बानी हामी त्यता नजानी त्यो त नराम्रो बानी हो सानो छ देश हाम्रो मिल्ने हो हामी तर दादागिरी होइन फेरि डेन्जर हो हामी
Are we allowed to switch really quick?
oh sure
Oh, I know.
it's okay
How long until this little one's ripe for breakfast? You know, like
that's my pet
that'll eventually grow into.
no not until she gets
Awesome.
old and
So you're gonna kill her when she gets old?
no
Weird.
I don't eat my pets would you eat your dog
I've tried. Are we allowed to switch really?
So the adjustment that needs to be made is to move our elbow outward to parallel our upper arm with the shot line. Then from here, it's just a matter of making a nice, smooth pool stroke. So the adjustment that needs to be made is to move our elbow outward to parallel our upper arm with the shot line. Then from here, it's just a matter of
अहिले मैले अगाडि ठ्याक्कै यो तपाईहरुको देख
Nobody tells you how much math. What is something that she can maybe work on that I kind of need to? Patience. Melody, come on, be patient.
Melody come on be
Come on,
patient
Melody.
अहिले के भयो मायाले बोलायो मलाई मायाले बोला
Morning. Someplace I have bro.
do you do this to yourself willingly has anyone ever sued you
where I have a single block and I want to make multiple copies of it. So here, this configuration on the right would provision 4 copies of this instance by passing that count into the resource, and then I can change the tags using count.index so that each one will be named server 1, server 2, etc. It's very useful to use this if you have multiple necessary resources that are nearly identical. Another important meta argument to call out is the for each meta argument. This is kind of like the count argument, but it gives us much more control over each resource. So whereas count, we literally just get 1, 2, 3, 4, etc. Here, we're taking an iterable of some kind, and we're using those to create the multiple resources. So in the example, let's say we had 2 subnet IDs up there on the top. We can then take those subnet IDs and go through them and do a for each, where each of those subnet IDs is used in our AWS
त्यही for लगाएको
instance config.
for लगाएको छ हरेकलाई सबनेट लिने सबनेटलाई चाहिँ फरमा अब सबनेट आइडीलाई पास गरेर
It allows us to very easily define copies of things while still maintaining the necessary control to individualize them as needed.
I've been using Grammarly for 3 years, and I can't imagine my work life without it. Grammarly is an AI writing partner, and unlike other AI...
We also have a lifecycle meta argument, and this is important because there are certain things where we need Terraform to take actions in a specific order. And so we can use the create before destroy argument to say, if we're replacing this server, we want you to provision the new one before you delete the old one. And so this can help us to avoid downtime for our applications if we do this properly. There are also some times where behind the scenes, after you've provisioned a resource, AWS or whatever service you're using will add some metadata to that resource. Those can be very annoying from a
मलाई मन पर्छ केटी नेपाली गाउँघर काली मोड्युल्स र इन्भाइरोमेन्ट मात्र छ हैन मोड्युल्स र इन्भाइरोमेन्ट छ अटो लोड ब्यालेन्सेसहरु त्यही यो त त्यही सोर्स भ्यालु 6 युज गर्ने नि के हुँदैन त्यही हो 6 युज गर्ने नाम चाहिँ त्यही भेरिएबल डट नेम छ नि त नेमको भेरिएबल छ के सो इनपुट मैले दिने टाइपको भयो कि त्यो चाहिँ मैले दिने जस्तो भयो लोड ब्यालेन्सरको नाम दिनु पर्यो राइट बीबीसी को नाम दिनु पर्यो डिफल्ट भनेको 80 भयो हेल्थ पार्टमा केट्ने भयो र हेल्थ इन्टरभल भनेको डिफल्ट के नदियो भने के नि हुँदैन आई गेट इट तर नाम चाहिँ दिनुपर्छ नाम र बीबीसी आइडी दिनु पर्यो लोड ब्यालेन्सरको लागि त्यो भन्दा अगाडिको लागि बीबीसी चाहियो भेरिएबलको लागि के छ आउटपुट चाहिँ के लिने के लिइराछ भनेको यस बीबीसी देश आइडी भन्नु चाहिँ बीबीटी आइडी चाहिँ त्यहाँदेखि निकालेको आइडी त कहाँदेखि आउँछ भन्नु मलाई मन पर्छ केटी नेपाली रिसोर्स बीबीसी भयो अनि देश भन्ने नाम दे नाम दे त्यहाँ ट्यागको लागि हो नेम डट नेम यता देखा नि त नेम भन्नु दिस जस्तो सिआइडी भ्याल्यु इनेबल होस्ट नेम के चाहिँदो रहेछ सर जिबिटी हाने पछि डक्स यो भयो बीबीसी आइडी कसरी गर्छ फर लगाउने हरेक पब्लिक सबनेटको लागि र प्राइभेट सबनेटको लागि भयो फइजको लागि कति पातलो कम्मर ठीक छ तर मोड्युल्स चाहिँ मैले मोड्युल्स हुँदै बनाएको छ यो पछि मोड्युल्स चाहिँ छ होला सायद मोड्युल्स डेमो होला मल्टिपल डेमो अनि सक्यो म हेर्दैन अर्को automated testing दिनु पर्दैन
a Terraform state perspective because it looks as though you have a change between your state and the deployed infrastructure and so you can put that in. The other not delete, you can add or some action either locally or on a remote machine. There's a number of different types of provisioners. There's a file of provisioners, local exec, remote exec, etc. There's also sometimes vendors publish a specific provisioner that allows your Terraform config to essentially call out to one of these other tools and do whatever it needs to do. So maybe if we're using that pattern I talked about with Terraform as a provisioning tool and Ansible as a configuration management tool, perhaps once you finish your application of your Terraform config and you have your server up, you can use the Ansible provisioner to then go off and install and modify those servers, etc. And so these provisioners are how you would go about actually making that happen within your configuration. Or in a more simple example, we could have, let's say, a startup script that we wanted to execute after we have provisioned our servers. And so that could be a file provisioner with a bash script stored there that the Terraform configuration could reference. So those are just some examples of how these provisioners would be used. For this part of the course, I haven't actually made any direct changes to the configuration.
Auto scaling group चाहिँ सक्दैन होला auto scaling ग्रुपमा लेखेको त छ युजर डेटामा इन्जिनियर्स auto scaling ग्रुप हैन युजर डेटा छ युजर डेटा भयो सेक्युरिटी ग्रुप्स यो इन्ग्रेसको लागि अलाउ गर्न खोजेको के कस्तो के गर्न खोजेको भने हो इन्ग्रेसको लागि फ्रम CIDR को लागि गर्ने इन्ग्रेसको लागि के गर्ने लन्च टेम्प्लेटमा आउने भनेको थियो लन्च टेम्प्लेट रिसोर्स लन्च टेम्प्लेट LT भनेको कति प्रिफिक्स नेम यति यति इन्टरफेस भनेको कस्तो सेक्युरिटी ग्रुप हालेको क्रिएट बिफोर डिस्ट्रोय ए अनि बन्द गर्दाखेरि चाहिँ अर्को लाइफ साइकल यो मेरा डेटाको लागि हो जस्तो लाग्यो auto scaling group launch template security group launch template auto scaling group चाहिँ कुनमा हाल्ने भनेर सोच्नु पर्यो
of our web application, we will start to use some of these language features as
डेपको लागि चाहिँ भेरिएबलहरु बार हालेको जस्तो लाइक भेरिएबललाई पहिले केही दियो भने चाहिँ त्यो मोडुल्स भयो कि साइडको हुन त एउटै हो मोरललेस एउटै हुनुपर्छ भन्ने कुरा हो यस पब्लिक सबनेट प्राइभेट सबनेट 24 इजी छ इजी भइहाल्यो CIDR पास गरेको छ
as we do things like break it out into a staging and production environment, we'll start to look at using conditionals and other language features. In this portion of the
मोड्युल्सलाई हामीले माथि डिफाइन गरेको छैन नि त हैन र डेभको मेनमा मोड्युल्स ओके तर त्यो चाहिँ रिसोर्सेसको टेराफर्म ब्लकमै गरेको भए चाहिँ बल्ल आउँथ्यो राइट हैन र भन्नु खोजेको कस्तो भन्दा यो मोड्युल्सहरु भयो यसकोमा चाहिँ यहाँ टेराफर्म प्रोवाइडर भयो त्यहाँ चाहिँ मोड्युल्सको नाम दिएको भए चाहिँ बल्ल माथिदेखि हेर्थ्यो होला तर यसमा त यही गरेछ भने चाहिँ यही लोकल्ली मोड्युल्स भित्रको चाहिँ यो नामको हेर भन्न खोजेको आउटपुटले के दिन्छ आउटपुट दिने अनि आउटपुट दिने डेटा भनेको लिने त्यही त हो नि डेटा यहाँ दिएको छ डेटा भनेको लाइक एक्जिस्टिङ रिसोर्स ब्लकहरु युज गर्ने भन्नु खोजेको यो ब्र्याकेट
repo, I've just included a short README that summarizes some of the various features here. But really, the best place is to go within the Terraform documentation here and use it directly, because it's going to have the most up-to-date and detailed reference available. In this next section of the course, I want to talk about how you should be organizing your projects and how to use modules to make your code reusable, as well as we'll take a look at how to use external modules. If we want to provision something that is pre-configured by someone else. So what exactly is a module? It's essentially a container for taking multiple resources that we've defined within our Terraform configuration and bundling them up in a reusable fashion. And it just consists of a collection of our .tf, our Terraform files, and or our .terraform.json files if we structured them as JSON files, and we keep them together within a single directory. So we've already been using a module so far. We just put everything into kind of that default module. But in this section, we're going to show how to break those out and bundle them up in a reusable fashion. And it's the main way that we can take our Terraform configurations and reuse them across projects or across environments, or share them externally if we think third parties might find them useful. Why would we care about doing this? And so we've got all these software engineers, and so we've got our web application, we've got some asynchronous processing system, we've got microservice A, B, and C, and so here everyone needs to know a little bit about everything, and that is not typically.
Hi, my name is Bruno Breezy. I'm a creative.
The breakdown that we want within our organization. We want to be able to have some people who can specialize in infrastructure and other people who can specialize in application development. You can't expect everyone to know everything, and so in order to make this manageable, we need to break down the system into different components. And so maybe we have a handful of infrastructure specialists who are really good at Terraform. Hopefully that will be you after completing this course. And they can define the infrastructure around how we want to deploy our web app and how we want to deploy our batch processing system and how we want to deploy our microservices. And they can abstract that away from the application developers who can then consume it. So maybe for my web application that my company is deploying, I need a web server, I need a database, I need some networking config, and I can bundle that all up in a Terraform module that an application developer can then say, I have my Ruby on Rails app, I just need to plug in these specific values, provision a copy of this Terraform module, and now I'm good to go. And I can have the best practices that the infrastructure specialist knows and has baked into this config without needing to understand fully what's going on under the hood and learn Terraform to a great extent. There's a few different types of modules. I mentioned before, we've been using modules because the default module is just every TF file in the main working directory. So kind of by default, by accident, we've been using this root module. We also can have
default all TF file working is
child modules, which is a separate module that we reference from our root module. These modules can come in through a variety of sources. If they're all in the same file system, we can have local paths. So I can have a directory A and a directory B, and I can reference one from the other. So that's the local paths. These also can be in the Terraform registry. So like the providers live in a registry on Terraform system, we can also have modules that live in a remote registry, and we can reference those directly. We can have modules that live in GitHub and reference them via a GitHub URL or other version control systems.
त्यो त्यही मिटिङ पछि त्यो ललितपुर प्लाजामा गएको थियो थाइल्यान्डको थियो किनकि थाइल्यान्डको कल्चर प्रोग्राम थियो कि त्यहाँ भोक लागेको थियो मजाले के खाइयो भने खै केले फुड पोइजन भयो मलाई चाहिँ एलर्जी रहेछ कि के को एलर्जी रहेछ क्या खै के को भन्यो साथीलाई के भन्नु मलाई चाहिँ अर्को दिनदेखि मलाई चाहिँ स्याटरडे मलाई चाहिँ बेलुकादेखि पेट दुखिरहेको थियो अनि त्यही भमिटसँग भयो अनि त्यहीँ बसेको अनि के ब्लड टेस्ट के भन्दा अरू केही हो कि भन्दा के एलर्जी टेस्ट यता के गर्न लाग्यो गर्नु
systems. They could live in S3 buckets. So there's a number of ways that we can reference these, but just knowing how to do it for various examples is the important piece here. A local path, as I was and you would just use a relative path from your root module to wherever that child module lives. So let's say I'm building my module web app. I just use the ... for parent directory, reference the web app directory. If it's living in the Terraform registry, we would specify it like such. So the source would be whatever organization / name of module. And so that's how we would do that. And you can pin a version so that you don't have any surprises about it changing in the background. For GitHub modules, you would reference it using either over HTTPS. This is named similar to sections. We looked at Git sources. In previous sections, we looked at input variables and how they can be used when we're issuing our commands. Those were for the root module, but each child module can also be passed inputs in a similar fashion. So we can specify whatever the developer of the module has exposed as an input variable, we can specify. And this is how we can have one module that is very generic and applicable to a variety of different sources. So we can specify things like the bucket name or the domain, and we'll see this when we actually refactor the example code and turn it into a module. These are the types of things that we will want as input variables to that module itself. You can also then use the meta arguments that we talked about before. Like if we want to have multiple copies of this, we would use the
थोरै बिराम भयो खोइ सर खोइ फुड
count or the
डेङ्गु हो कि भनेर चाहिँ गइरहेको छ सर
for each meta argument to specify the number of copies and the attributes of those copies. Similarly, we can use the providers and the depends on meta arguments as well. Now, what makes a good module? Now, what makes a good module? You can put anything you want in a module. Depends on. Meta arguments as well. Now, what makes a
दुईटा अभाइलेबिलिटी छन् इन्टरनेट गेटवे ल इन्टरनेट हुनु गर्दा इन्टरनेट छ हुनु अनि मलाई चाहियो नि त इन्टरनेटलाई गर्नुपर्ने लोड भइहाल्छ त्यही लोड भइहाल्छ त्यही टार्गेट ग्रुप छ त्यही इन्टरनेट गेटवे अट्याच हुन्छ लन्च टेम्प्लेट बनाएको छ लन्च टेम्प्लेट ज्याक्ट हुने बेला आइसक्यो ज्याक्ट हुनुपर्छ अब
a good module. You can put anything you want in a module. You could have a mega module that had everything you wanted. You could have a tiny module that's just a very thin wrapper over. I'm gonna do a few things within this demo portion. First, I'll show how we can consume a third-party module, and I'll deploy this console module. Console is another HashiCorp tool, and we will deploy it using this third-party module. It is available via the Terraform registry, and I just want to show how we can take advantage of them configuring this system with a lot of the best practices and exposing the key input variables to us. So they've abstracted away a lot of the complexity that would be required to run console. If we look at this README, we can see that this is actually going to deploy a ton of resources behind the scenes, but they've only exposed the important pieces that we would want to make when actually going about and deploying this, so that we can let them handle most of the setup and we can configure it to match our needs. So I'll just go ahead and
give yourself 28 days and become the most dangerous person in the room. Let's be real. Most people over 40
show you this within the console subdirectory. I've got a main.tf. Again, we always set up our backend and providers, but then we can just reference the console module via the GitHub repo that it is stored in. And so if I navigate to that directory, do a Terraform init, and then a Terraform plan, you'll see this would actually provision 52 different resources within our AWS account. So things ranging from EC2 instances to networking policies to IAM roles. And so console is this relatively complex system for for automating a lot of the network setup and discovery if you have many different services. It would be very difficult for us to go off and deploy this, but because they've built a public module, we can actually consume that module and just configure it exactly how we need using the smaller set of input variables that they've exposed to us. Now let's take a look at the web application that we're building and configuring.
So all the full access like उस वाइज चाहिँ के अरे रिसोर्स वाइज चाहिँ फुल एक्सेस छ जस्तै EC2 फुल एक्सेस छ, लोड ब्यालेन्सिङ फुल एक्सेस छ, अटो स्केलिङ क्लाउड चाहिँ छैन त्यो EC2 फुल एक्सेस त छ अनि लोड ब्यालेन्सिङ फुल एक्सेस चाहिँ छैन।
And see how we can turn that into a more modular configuration. And so the first major thing that you'll see if I go here I've broken it up into those different portions of the architecture. I've put the compute in one place that's going to contain the EC2 instance definitions. The database is here. Storage is going to contain the S3 definition, networking, etc. So I've broken it up into the different components. I've kept our variables.tf file. I've added a few here that we can take a look at, including the environment name. So this is going to allow us to split on dev versus staging versus production, and avoid some naming conflicts because I'm deploying into a single AWS.
सिक्स हजुर काय अब त्यो अपडेट गरिदिएको छ र
account. So now our main.tf, all it contains is this base block in which we specify that we do need that AWS provider. And then each of these blocks, I've copied and pasted out the definitions of our specific resources into the corresponding .tf file. You'll also see we don't have a tf-vars file here. We'll define the tf-vars file where we actually consume this module. And so I've got the web app module here. In this web app directory, I've got our main.tf file, and I'm going to show how we can consume our module and deploy two different copies of it very easily from within this one configuration. So I'm setting up our backend and required providers as usual. I'm then setting up a couple of variables that we're going to want to pass into our configuration. Let's say we want two different passwords, one for database 1 and one for database 2. These are of type string and are sensitive. We can then reference the module using the relative path, since these are both in the same file system. So I'm just going up a directory into web app module. And then I define all the input variables that that module consumes. So whereas before we had a tf-vars file that we were passing in at runtime, now this module has those variables defined. And when I consume it, I define all the different values here, except I once again want to keep my password, which is a sensitive value, out of my code base. So I pass that in as a variable to this configuration, and then that gets passed through to the module that we're provisioning. I can then have a separate block where I define another copy of the web app where everything is quite similar, except I've incremented this from 1 to 2. And so just by having these two blocks, I can consume that module in two places and have a slightly different configuration. So here, maybe we're deploying devopsdeploy.com, and then here we could deploy another devopsdeploy.com. I'll go ahead and actually apply this, and we'll see two copies of our web application being provisioned into the account. Make sure we're initialized, and then I'll apply. Because I didn't pass that db password, dbpass1 or dbpass2 on the command line, it actually is going to ask me for them here in the prompt. So I'll just enter some values, and that should be enough for now it to go off and provision two copies of my web app. Also, dbpassword, dbpass1 or dbpass2 copies of our web application being provisioned into the other different config ones. I then have a separate block where I define another copy of the web app where everything is quite similar, except I've incremented this from 1 to 2. And so just by having these two blocks, I can consume that module in two places and have a slightly different configuration. So here, maybe we're deploying DevOps.
यो फेरि डाउनलोड गरेर नाम छुट्टै चाहिँ भयो तर No, there is.
deploy.com, and then here we could deploy another DevOps deploy.com. I'll go ahead and actually apply this, and we'll see 2 copies of our web application being provisioned into the account. Make sure we're initialized. And then I'll apply. Because I didn't pass that DB password, that console deployment, you should have a pretty good idea of how to build a configuration using Terraform. Now I want to move into how we use Terraform to manage multiple environments. So if you think about having your web application, like this example that we've been building, it's built with these different components, and that's great. And we've defined those as a Terraform configuration that we can deploy. But now, in addition to a production environment, we also want a staging environment. We want to have them be very similar so that we can be confident as we make changes. We can test them out in staging and see how it goes. We also may want a development environment that we're deploying to all the time, rapidly changing, testing things. And so we want to take our single config or module and deploy it multiple times. And there's 2 main approaches that people use when doing this sort of thing. The first of which is a concept called workspaces. And so this is how you can use multiple named sections within a single remote backend. So if we've got our S3 backend or our Terraform Cloud backend, we can use the Terraform workspaces command to create and manage these different environments or workspaces that live as different files within our different state files within our backend. And so we could say, switch to the dev workspace, deploy that, switch to the staging workspace, deploy that. And so that is one method. The other method is to break things out as different subdirectories within your
अनि त्यही फाइल स्ट्रक्चर बाहिरै उसको आएछ हाल्नेछरीमा ब्याकेन्ड त बुझ्न म त पहिला एसए हाल्ने रे अनि पहिला एसए हाल्ने रे फेरि प्रोभिजन पनि गर्ने रे के पहिला हो के पछि हो हाल्न सक्दैन मलाई मल्टिपल नेम ब्याकेन्ड
file system. And so here we see on the right, we can have our modules directory, which has the different modules that we built. And then we can have a dev, staging, and production subdirectory, which consume those modules in different ways. And these 2 approaches have pros and cons that I'll talk through here in a second. Now, Terraform workspaces are good in some ways and bad in others. They are easy to get started with. It's very convenient because within your Terraform files, you can reference terraform.workspace as an expression to, let's say, populate the name of your resource. So you could call your database the staging database or the production database. And so it can make it very easy to handle that. It also minimizes the amount of code duplication you have between your different environments. So you have one copy and you're deploying it multiple times through these different portions of your remote backend. The downside to workspaces is that if you are interacting with these things manually, it can be very easy to forget which workspace you happen to have configured and make a change and apply it to the wrong environment. So let's say you made some change, you thought you were in staging, but you were actually in production, and you hit the button, it causes an issue, and that's no good. So if you are manually interacting with this thing, workspaces can be dangerous from that perspective. If you do, and that's no good. So if you are manually interacting with this thing, workspaces can be dangerous from that perspective. If you've automated a lot of this and it's all happening from within a pipeline, that can be less of an issue, but it's still something to think about. Another con is that the state files are all stored within that same remote backend. And so permissioning and access to those different environments, you can't really isolate them. So if someone has access to the development space, someone then also generally has access to the production space. Within the cloud offering that Terraform, HashiCorp provides, there is some more nuanced configuration there, but if you're using a self-managed backend, this can be a challenge. Also, just by looking at the code base, you can't tell specifically what's deployed everywhere. You can tell we have this configuration, but until you've issued some Terraform commands, you can't tell, oh, here are all the places this is deployed, and here are those specific configurations. So it can be a challenge just looking at the code base to reason about specifically what's deployed everywhere. The alternative option that I described is to put these things into different subdirectories within your file system. This is nice for a few reasons. One, you can isolate the backends. You can have a separate backend configuration for production, from staging, from development, which is good from a security perspective. You can handle the permissions for those backends differently. It also, I think, decreases the potential for human error of thinking you're operating in one workspace while you're actually operating in another. And then finally, looking at the code base, it fully represents the deployed state. So you can see, here's my production config, here's the variables I'm using, and here's the staging config, and here's the different variables I'm using. And you can look at it and very clearly see we've got these environments deployed, and here are their configurations. Some of the cons here are that because now these are living at different places in the file system, if we want to apply to each of them, we've got to navigate between those subdirectories and issue those multiple Terraform apply commands. Also, we have more code duplication than in the workspaces style, because each of these main.tfs represents a very similar configuration, and therefore that code duplication, it can be hard to keep things in sync across them. And so that could be considered a downside there. Now, depending how complex our infrastructure is, we probably want to start separating things out into not just having a single massive Terraform config for all of our infrastructure. If you're a small company with just one
Fuck off you bitches. Fuck you. Sorry.
or a few applications, then maybe having everything in one Terraform config is fine. But as your organization starts to grow and your infrastructure becomes more complex, you probably want to break things out into logical component groups rather than have everything bundled into one section. So let's say here, let's say we want to break our compute away from our networking. If one changes more frequently than the other, that can be a good way to think about Terraform workspace. Create this resource. If it's a 0, we will skip it. Here, if it's a 0,
आएको छैन यति भएपछि ठिक छ अब केटा हो अब चाहिँ कुबरनेटिसको छ अप्लाई गर्न खोज्छु